I don't know where I suddenly became Abiquo. Abiquo, we usually say. Good morning, thank you. So, ops or apps? Who will own the data center of tomorrow? Good question. Let's take a look. So, first of all, we need to go back and look at a little bit of history and consider this premise. The IT operations model hasn't really changed in 30 years. Sounds strange, doesn't it? But think about it. The model is increasingly failing to meet the needs of the application side of the house, and the situation is not sustainable, and it's got to change, but how? So let's go and have a look at a little bit of history. A little timeline there, just to remind us where we've come from briefly. Right back in 83 there, Novell brings in the local area network, whatever happened to them. Right to 1990, we start to get the World Wide Web. VMware Workstation gets introduced in 1999. Along comes Salesforce in 2000. Amazon Web Services in 2006. And you get to the end of 2010, and this is big business. VMware revenues for 2010, $2.9 billion from pretty much nowhere. You can see the sort of timescale there. 10 years, pretty good stuff. And here is the cloud coming in, just at the end of that. And it's the cloud that's causing us to think about this in a different way, as you'll see. So we've got 27 years of client-server computing, 20 years of internet, 11 years of virtualization 1.0, if I can call it that, and 10 years of the cloud. Phenomenal, unprecedented growth of applications. But we still got the same old infrastructure management model. So, unprecedented growth of applications, unprecedented growth in complexity, renders the current IT management model unsustainable, and we've got to change it. The model must evolve. But how? So the big point that everybody makes is self-service is the answer. And self-service may be the answer, but we need to look at what self-service really means, what the requirements of self-service are. So what are the perceived benefits? We all know about these. Rapid provisioning, agility, get past the bottlenecks of IT and its bureaucracy, have what you want, when you want it, ultimate agility. The pay-as-you-go model, where you don't have to go and outlay big amounts of capital. You can do short-term projects. As we said, in a very agile, very instant way, the Amazon model that we all know about works great from a benefit perspective for the customer of that service. And it doesn't necessarily work well for the organization, for the IT organization, or for your compliance or your security questions, all those sorts of things, but it works great for the customer of that service. And you can have pre-built configurations of stuff. You can have, Amazon allows you to do things really easily. It's got a whole bunch of kind of predefined services available to you. Great, fantastic if you're a customer. And also benefits for the infrastructure organization. If you can have that kind of a model, where it be it private cloud or public cloud, it's going to take load off your IT infrastructure team. That team is already overstretched, and as we talked about in my session yesterday, the time it takes to provision even a virtual machine using the traditional IT infrastructure model can still be weeks in many organizations. So the time that those guys are spending doing that rather monotonous stuff of provisioning machines disappears. That's great. So they can focus on the physical infrastructure, maintaining that to the service levels you want, doing capacity planning and all those sorts of things. They're not distracted by that provisioning task, which takes up huge amounts of time. That's why it takes so long to get there. We can eliminate the deployment risk. We don't need to let users get near physical hardware. The self-service model allows you to provision, but it doesn't allow you to get near the hardware. You don't need to be near the hardware to do it. This system does that for you. So we're not introducing any risk there. We can maintain standards because we can provide service catalogs and libraries that have standard gold images that the organization has specified. Here's our standard Windows 2008 server with all of the tools that we need, all of the antivirus that we need for our corporate standards, all ready for us so we can help our users to maintain the standards that we want. And we can increase utilization. These are the perceived benefits to the infrastructure side of the house. But there are risks. And the risks depend on, partly on whether you're on the private cloud or the public cloud side. But the first issue is that most of these solutions are black boxes. And as we talked again about yesterday, that gives you real issues in visibility. You don't know what's going on inside the black box. You don't have any control over what's going on inside the black box. And you can't always test the resilience of that solution. As we talked about again yesterday, the Amazon downtime that we had a few weeks ago illustrates that even though you think you have a resilient system, because you don't own it, you can't test every different part of it and make sure it's going to be resilient when you need it to be. Security, compliance, governance, big issues there. How are we going to resolve those? Again, we talked about solutions for that yesterday. The area of over-provisioning. If your users are allowed to do their own provisioning in the self-service model, how do you make sure that over-provisioning doesn't occur? In other words, they consume more than you want them to. In the private cloud model, that equates to eating up all the resources that you've got, and that could bring the whole house of cards down. In the public cloud scenario, that equates to cost overruns, unexpected costs that, that there is no control over those in the public cloud mode. Of course there isn't. Amazon wants you to spend as much as possible. And lastly, portability is a big risk. Again, particularly on the public cloud side, you develop your application, you change your application so it will work on the public cloud side, introduces a portability risk because it's then not easy to bring it backwards if there's an issue. Just to dwell on utilization just for a moment, this model shows us how utilization has changed with virtualization. And remember, the big premise of cloud is it's going to reduce cost. The big premise of virtualization is it's going to reduce cost. Not the only one. Virtualization is certainly, as I again mentioned yesterday, added in lots of ways around sort of resilience and portability between machines and that kind of stuff. That's good. But it hasn't really solved the utilization problem. You can see with virtualized environments, it's gone up. In some cases nearly double, but it is nowhere near that 70% nirvana, which is where we start to make real cost savings. Previous speakers have mentioned that cloud is not necessarily going to be a cheaper option for you. This is why, and we have to resolve that. We talked about policy-based allocation as a solution for some of these issues, both functional. So this is remember, policy-based allocation is the moment at which your self-service system decides it's going to deploy a virtual resource in the physical world. Every virtual resource has to exist somewhere ultimately. That decision needs to be made, it needs to be automated, otherwise it won't be self-service. But there are very key pieces you need to do to make sure that all of the risks you have are dealt with. So, particularly the compliance, security, governance, utilization, those sorts of things. So you've got the functional stuff. Where in my infrastructure where in the physical world will this thing actually run? Where have I got the right servers running the right hypervisors with the right resources available? The kind of obvious stuff, if you like. Then standards around data security. Again, we talked about policy saying, for example, where am I going to allow this application to run? This is my trading application. It's got to run on hardware that I own, might be your security diktat. So that kind of thing. Other issues around compliance, the classic Wall Street example of segregating this business unit from that business unit. Research analysts may not be on the same physical hardware as investment bankers, for example. And lots of, that's a sort of classic well-known example, but there are lots of others where it's not allowed to share hardware for compliance reasons. And then governance rules around, for example, I used the example yesterday of HR in Europe. It is illegal in Europe for HR data to cross a country boundary. In a virtualized environment in a cloud, how are you going to make sure that's enforced? You do it using business policy that says, for this HR organization, let's say the UK HR organization, we're only going to allow UK data centers to be used for that. It's how policy can address those things. And then operational issues, we've talked about utilization. How do we make sure, again, we showed some examples yesterday of how utilization can be performed according to whatever the policy you want. Taking two extremes, it can be performance-based, where you spread the load of your virtual assets right across your physical assets in as kind of thin a layer as possible to maximize performance, doesn't do much for energy saving, but if that's what you need, performance, then that's one mode. Or the exact opposite to that is what we would call a progressive policy, which basically says fill up one machine completely, one physical machine completely, before you even turn the next one on. And we'll talk about load balancing in a little more detail later on. And then lastly, preferences around how you want your, from the application side of the house, how the application needs to run. For example, we talked about, does the application need to be co-located with another application for performance reasons? Or does it not need to be co-located for resilience reasons? Make sure that you can determine where that thing is going to run, not just a very coarse geographical, with Amazon, for example, I can choose, Eastern US, Western US, Europe, Asia, I'm limited to those sorts of things. I may want much more granularity than that. So, policy-based works for those sorts of things. But let's talk about some more different areas that might not be quite so obvious that you need to consider for a self-service model. Goes back to our vision that Abiquo has about the world. I'll briefly recap this for those people who weren't here yesterday. In our vision, the physical infrastructure is represented by the grey ring around the outside of this diagram. And that is your physical hardware, your compute, your storage, your networking, which may exist in a variety of different places. It may be in data centers that you own locally. It may be in data centers that are remote, conceivably anywhere around the globe. Or you may want to get that physical resource from a hosting provider. You may even want to get physical resource from a public cloud provider like an Amazon or a Microsoft Azure. Those would all contribute to what we call the resource cloud, which is just a notional term, and it's there to show you the clear division between the physical infrastructure and what we call virtual enterprises. These are the self-service units. Each virtual enterprise is completely autonomous. It can do and operate exactly how it wants, but there are, as we've talked about, some real essential elements that you need to make that work properly. Lastly, in this diagram, we have image libraries, which again we talked about briefly just now. This is it can be thought of as your self-service catalog, where you can get that standard Windows 2000 server, or you can keep copies of the virtual machine images you've taken, snapshot copies, all that kind of stuff. So the first real key you must make sure that a self-service model has is full empowerment for those users. And full empowerment means empowerment that you can provision all of the resources you need. It's no good just having a subset of them. And I urge you to check out products that you may look at in this area to make sure that you can do all of the self-service needs, because if your user has to go back and call IT for anything, the model doesn't work. So what I mean by that, well, everybody more or less gets the compute bit right, and you've heard lots of discussion about provisioning servers, launching virtual machines. That bit most people get right. The second part, though, is the storage. Can I provision storage? It's no good, again, if I have to call the IT guy up and say, can you create me a volume to use? That doesn't work. You've got to be able to do it yourself. And that means you've got to be able to, under the covers, the self-service model has got to be able to go to whatever storage devices you're using, NetApp, EMC, HP, whatever they are, go under the covers, be able to provision you storage volumes, attach them to your VMs, and to give you full flexibility on the storage, again, without intervention. You've got to be able to do it yourself. You've obviously got to support a wide variety of devices, but you don't want to present devices to your users. In the self-service model, you want to be able to choose a class of storage that you want. You don't want to get near working out what kind of physical devices you want. So your physical devices would stand behind a tiered model where each tier of storage represents a particular class. So, give you an example. At the top end, you might have your class 1 of storage. Tier 1 might be storage that's replicated in several different data centers, that's very high performance and consequently high cost, whereas your tier 4 storage might effectively just be cheap JBOD storage. And you would, in a chargeback model, you charge according to what your users would use. And the only thing that you need to know in the self-service model is what tier of storage do I want. I don't care what devices it's on. I care about what tier and what service level of storage I've got. And you can have multiple storage devices contributing to any one of those tiers. And you can also have the same storage device contributing to multiple tiers if you've configured the performance and availability and those sorts of things accordingly. So on many sophisticated storage devices, you can have different aggregations which have different performance characteristics or different resilience characteristics around them. All of that stuff you need. And lastly, you need networking. And I'll come to, again, to a bit more about this in a moment or two in a bit more detail. But you need, first of all, automated isolation. Whenever you create a new unit, we would call it a virtual data center, you want to make sure that that is automatically isolated in network terms from every other unit you've got. You want to give users the ability to create their own virtual LANs if they want to. Again, no good going back to the IT guys and saying, I need you to create me a virtual LAN. You broke the model. You need to be able to manage your own firewalls, load balancers, all of that kind of stuff. You need full flexibility to do that. You don't want to be constrained. Now, that's not to say that the organization won't have additional firewall and load balance technologies that it's implemented at an infrastructure level, but you need to also be able to put your own at a virtual level, at a virtual data center level, if you choose to have them, and to be able to configure them, again, without going back to your IT organization. They may deal with the basic sort of denial of service stuff and those sorts of things. You need full flexibility to configure everything else. You don't, if you need the port to be opened, you've got to be able to do it yourself. So just think about the user model, for example. Now, we obviously are delegating, the whole point about self-service is you're delegating authority for users to do this stuff themselves. But is it just users? Is it this flat model we're talking about here? At the top, we've got the traditional management model. The IT infrastructure organization does everything. That's the model that doesn't work because it doesn't scale. That's why your IT organizations are completely overworked. In the user model, we're saying, OK, we will empower individual users to be able to do that stuff. But empowering individual users is not enough. You need a tiered model where you empower groups of people, and they can, in turn, subdivide that and empower their own groups in levels below. So let's take an example of that. Let's say that we create what we call a virtual enterprise, and we set the resource limits that that virtual enterprise can consume. Remember we talked earlier about it's essential to have limits, otherwise people can go ahead and provision vast amounts of stuff, and you can run out of physical resources, and the whole thing can be uncontrolled. So you've got to have levels of control. So I might say, for example, to that top tier there, OK, virtual enterprise X, you have 50 virtual CPUs that you can use. You have 20 gigabytes of memory. You have 5 terabytes of hard drive. You have, 20 public IP addresses all available to you. You can do whatever you like within those limits. But in the tiered model, you can then say, I want to create subunits beneath me. I want to create virtual data centers in our parlance beneath me and impose limits on those. So I have limits imposed on me from above, but I want to impose limits downward as well. So you need the tiered model to do this effectively. And that obviously, the larger your organization, the more important this is. And you need it, of course, to map to your LDAP system and all that kind of stuff so that you're not provisioning individual users. You need it tied to those sorts of systems as well. Let's just talk about the virtual enterprise for a minute and just give you just a little bit more flavor about that. So a virtual enterprise, again, is a logical unit. And we might, for example, have a virtual enterprise for our trading operation. It's application-centric, typically. So we have one for our trading operations, and we decide that we are going to, first of all, appoint our own users. So we appoint somebody to be the first administrator of that virtual enterprise, and then we allow them to appoint their own users. So again, self-service isn't just about deploying technology. It's also about managing your own set of users at the enterprise level. Then I have 2 virtual data centers that I've created here. Remember, subdivision down from that. I can allocate some of those users to just one of those data centers, or I can allow them to manage both, whichever I choose. And I can make those virtual data centers geographically located in different places, obviously, as I've chosen to do here. And then within each of those, I can define my own compute, storage, and networking. Each virtual data center acts as if it was a physical data center. Imagine your own physical data center locally in your office. You could go in and you could reconfigure that however you wanted. You could change all the networking. You could rewire it, all of that stuff. You need to have the same capabilities in a virtual data center. Networking flexibility is incredibly important, and I'll just give you a few pointers to how this needs to work. First of all, it must be highly scalable. You need to be able to make sure that the environment can cope with as many switches and racks of servers and that kind of thing as you might need. It has to be very scalable. You might want hundreds. You might need thousands of virtual LANs. You need to have that capability. You need to be able to use commodity hardware. If you have to go and buy very specialized switches, they are very expensive. So you need to do this with commodity hardware that you can buy off the shelf from anywhere, so you're not making dramatic costs there, otherwise you defeat the object. The management of the VLAN tags must be completely automated. You do not want your users anywhere near VLAN tags, because if they can mess with VLAN tags, they can go and change them and look at other people's networks. That part must be automated in the provisioning. Just like you don't want them to get near physical servers, you cannot allow them to get near VLAN tags. Isolation must be there by default. So whenever you create a new virtual data center or a new virtual enterprise, anything within it is automatically totally isolated from anything else. You must be able to have an unlimited number of virtual network interfaces in each of your virtual machines. You'd be amazed how many products can't do this. Having just one virtual interface is no good, because if I want to create a virtual LAN, for example, I create a small web farm, I want to be able to have a virtual LAN operating internally within machines in that environment, but I may want to obviously have a public IP address to talk to the outside world. So at least my load balancer machine that I have, my virtual machine running a load balancer at the front, has to have at least 2 virtual networks on it, virtual network connections. Okay, you need an unlimited number, or a practically unlimited number. You need to have configurable naming for your virtual LANs. Again, numbers aren't at all helpful. You need, for example, on the one I talked about, on the web farm example, you need to be able to call it web farm internal or whatever, so that you can describe it. Again, you don't want users near the tagging identities, and nor do you, want descriptive names so that it's obvious what's going on here. You need unrestricted network addressing. Users need to be able to define VLANs with whatever numbering scheme they want. And the VLAN isolation makes sure that there is no conflict with the same numbering that may have been defined in another installation. Very, very flexible. Obviously, you need to be able to allocate public IPs. You need to have a pool of public IPs available to each of your virtual enterprises and in turn to your virtual data centers, so they can pull from that pool. And obviously, those IP addresses need to be static. They can't change once you've given them that set. So they must be able to drop them, have them left in the pool, and then reuse them again if they want to reconfigure their network. And you must provide inter-site connectivity, because there will be times when you want virtual data centers that are physically located in different places. For example, we've intentionally done that so that we have resilience. My self-service model, I've defined that to have resilience. I need to still have means to create connections between those two VLANs in the physically different locations if I want to. All, again, without going back to the IT organization. That's critical. So I want to talk just for a few minutes about load balancing. And this is where it's an example of where taking a traditional virtualized environment that has management that's been added on the top of it, so hypervisor management put on the top, is not necessarily suitable for the self-service model. There are other things to think about. And load balancing is a very good example of that. This is what we call the break-fix model. And this is where you have products that, again, managing your collection of hypervisors in a cluster or a pool of hypervisors, where you submit your new virtual machine to the cluster or to the pool, and the hypervisor management product works out which physical machine to stick it on. And if you take this example here, what happens is, let's say we've got 4 virtual machines running. So there are our 4 virtual machines. They're each consuming 10% of the server's resource, so we've got 40% here. And so the load balancing model says, well, I can put more on there. We're only on 40% CPU utilization. Let's throw in a couple more, which it does in this next stage here, and now we've got 6 running. But what then happens if just one of those machines, which was in fact idling, suddenly decides to do its month-end processing? That's not something you can predict as a hypervisor management tool. So we suddenly leap on that machine from 10% utilization up to 70% utilization. And now all hell breaks loose, because we suddenly, just because that one virtual machine has increased its activity, in this example for month-end processing, the whole system has gone through 100% utilization. Now, of course, you can't have more than 100% utilization, so that means every other machine is going to be affected. And the traditional, what we call the break-fix model, then says, aha, something's gone wrong, I need to rebalance these servers. But rebalancing takes time. And the first thing it has to do is to work out that something's gone wrong, and that involves waiting for a period of time, because you don't know whether this was just a quick blip, or whether, if you look at CPU, typically, it occasionally will go to 100%, and 3 seconds later, it's back to normal. Is this a blip, or is this, a month-end processing that's going to take some time? How do we know? Well, the reason we know is because we wait and see if it stays doing it. And whilst it's staying doing it, of course, we've got a performance hit on all of those virtual machines running there. So we get to the point here where we've decided, okay, this has gone on long enough, we're going to need to rebalance. This could be 5 minutes, this could be 10 minutes, don't know. But the point comes when we decide we need to rebalance. And then we have to do a live move of one of those virtual machines onto another server. And we may do that in multiple stages. We may not take the really busy one away. We may take some of the less busy ones away. And in this example here, we start taking less busy machines away. So at this point here, we are trying to synchronize one of those machines with another machine on another server to do that live motion. And that synchronization takes resource. So performance gets worse. And now we're up to 130% utilization, theoretically. Of course, remember, that doesn't happen. You can't go over 100% CPU utilization. So what's happening is everybody is being crushed downwards in their performance. Everybody on that server is feeling the heat. And that keeps going, knocking off virtual machines until we get down to a state where utilization is acceptable again. Now, if you consider from the point of view, instead of looking from a point of view as the hypervisor, as we were doing then, consider what happens from the point of view of an individual VM. What do you see as an individual VM happening to your performance? This is what happens in that graph. I've got 100% of my capacity available to begin with, and it starts getting knocked down until I get to the point where I have only 50%. Everything is running at half speed until that goes through, and it steadily gets better as those loads get shed onto other hardware. Now think of that in the self-service model. In the self-service model, I bought that resource, and I expect it to be there. If I decide I want to run at 10% until such time as I do my month-end processing, I expect that other 90% to be available to me, and it's not. And that is going to cause you customer complaints. There's a different way to do it, what we would call the oversell model. And this is exactly the same model that airlines follow. You sell slightly more seats than you've got, but you know how much you've oversold, and you know what the consequences of overselling will be if everybody shows up. It doesn't happen very often. It's not very often that you get denied boarding because the airlines are good at working out how much to overbook by. Let's take and see what happens in this model. So here at this first place, we've got our original 4 machines. And I'm going to take some extreme examples here. I wasn't extreme on the previous example, but I'm going to be extreme here just to show you what the difference is. So let's say we have got a machine with 4 CPUs in it, 4 CPU cores. And we are going to say, right, here are our first 4 VMs running on there, and each one of those is consuming only the 10% as we had before. So our consumption on the machine is very low. But what we're going to say is, we're going to allow overbooking of that machine. We're going to allow overloading. And we're going to do it in a controlled way. And in this example, again, I'm going to take an extreme example. I'm going to say, we're going to allow this machine to be overloaded by 100%. In other words, it can take double the load. We're going to pretend it can take double the load that it really can. And so we allow another 4 virtual machines to come in here. And now we've got 8 of them running, all of them at 10% capacity. Okay? What happens when each of those individual machines, the first one comes and says, whoop, up to 70% doing our month-end processing here. Still way under the capacity of the machine, okay? And let's progress it. We only did 1 in the last example. Let's keep doing them here, and let's start bumping them all up to 70%, one after the other. That continues until we get to the point where all 6, the first 6 of those 8 machines, all of them have to get to 70% capacity before we actually hit that 100% level. So everything is fine until 6 of those machines actually get up to 70%. Not the 1 we had in the previous example, all 6. And obviously then if the others were to do that as well, we would get a further performance degradation. But look what the difference in the graph is when we consider the performance from a virtual machine perspective. Everything is fine. I get my full allocation of performance, my full CPU core that I bought is available to me right up until the point that I get 6 of those machines all doing the same thing. And the chances of all 6 machines on there, or all 8 machines on there, going to 70% at a given time is much more remote than just one of them, as we saw in the previous example. So this is a different way of load balancing, and it shows you you cannot necessarily take the traditional model that's been used and simply add self-service provisioning on the top of it. You need to think in a different way. The gap there obviously is very much smaller. It only gets to 30% degradation, and that has only happened when we've got all 6 of those machines, or 6 of those machines, 8 in this case, started to go when we got 6, and when we get to 8, the degradation only goes down to 30%. Now, I'm showing you extreme examples, but just think about it, it's a different way of doing it. The airlines do this for a reason, because it works. So let's summarize the requirements that we've talked about. A complete self-service model, it must be fully flexible. You must be able to do everything you could do in a physical data center. You must be able to provision your compute and your storage and your networking, otherwise it doesn't work. If you have to go and involve the IT guys, you didn't solve the problem. You need your virtual enterprises to be completely autonomous, self-determining. They need to be able to manage their own users and groups. They need to be able to delegate that control. They need to be able to set resource limits on the stuff that they've delegated. So you have a tiered model. You need a business, what we call a business policy, to make sure that that critical moment when you allocate a virtual asset into somewhere in the physical world, you follow a business policy. Humans cannot do that. As I mentioned yesterday, if you've got a private cloud environment that has 1,000 physical servers in it, there is no way any IT guy is going to be able to tell you which is the best machine to put that on to get the best utilization or to make sure that you've got all of the security governance and compliance issues covered. You have to automate it. And that has to be done according to a centrally determined policy that your organization determines. You need to have association and reservation. Association means I want to be able to say this machine is co-located with that one or it's not co-located with that one. We talked about that earlier. You need to be able to reserve particular hardware for a particular purpose. I bought those expensive machines of this particular type for a particular application. I want to reserve them for being used for that application. And lastly, you need auditing. You need to be able to say, for your compliance requirements, you need to be able to say, I want a complete trace of where that virtual asset was over its lifetime. Where in the physical world was it at any given time? Show me the trace of what happened to it. So again, this I showed you yesterday. It's worth repeating. Without automation, there's no such thing as cloud. Smarter automation will catapult cloud computing concepts through today's hyperbole, and boy are there lots of hyperbole, into a reality that will alter business flexibility. That's Forrester. Really key piece of information. Now, I'm just going to run again for you, as I did yesterday, the video that just shows you a little bit about what Abiquo does, and then I'll just finish up with a last couple of points.
Virtualization. Great, isn't it? We can move things around if the hardware fails or needs upgrading, or if we need more power. And we can move workloads around to more efficiently use the hardware we already have and stop us buying more hardware we don't really need. Yep, it's pretty awesome. Yeah, except for all the ways that it isn't. See, all this moving around does make it kind of hard to track where everything is. And working out just where to put everything to get the best utilization is actually pretty difficult, especially if you have to do it over and over every day. And what about governance, security, and compliance issues? Even so-called easy deployment is still a big headache for the overstretched infrastructure team. And of course, these problems aren't getting any smaller. But hey, why worry? Cloud computing is going to fix all this, right? What if the cloud could solve the problems of virtualization? If you could fully empower your users to manage their own environments without any risk to your infrastructure, freeing your IT team to focus on delivering the most cost-effective resources at the required service levels, and have it all automatically operate according to your organization's business policies. What if you could make virtualization and the cloud work the way you need them to? Well, they can. At Abiquo, we've created a solution that fixes all the old virtualization issues and delivers the cloud just the way you need it. Abiquo provides each organizational group with total control of its own virtual enterprise, where they can configure and deploy resources any way they want to, in seconds, and without any risk to the infrastructure or anyone else's virtual enterprise. Abiquo supports all 6 major hypervisors and ends vendor lock-in by providing drag-and-drop conversion of virtual machines between any of them. It lets your IT team manage infrastructure across the globe, whether it's equipment you own or services you buy in to provide elasticity, all through a single pane of glass. Abiquo lets you control resource consumption while providing drill-down accounting for billing and chargeback. Real-time displays and statistics keep you informed and make capacity planning and efficient demand-based elasticity a reality. And Abiquo's highly sophisticated business policy ensures governance, security, and compliance requirements, as well as your business goals, are consistently and automatically enforced every time. Come experience the industry's most sophisticated enterprise cloud management solution today. Abiquo.com.
So if you step out to our booth when the floor opens, we'd love to show it to you. You can come collect your leash to tame your virtualization monster. We gave away nearly 1,000 of these yesterday, but we still have some left. Just to finish up, let's go back to the original point. Will ops or apps own the data center of tomorrow? The answer is they both will. As we've talked about, the IT infrastructure organization will continue to own the infrastructure, but the application teams will have self-service provisioning, self-service control, and that won't necessarily be limited to virtualized environments. This model can go way beyond virtualization. It could go to physical environments as well. But self-service provisioning is the answer. It's just what kind of self-service provisioning and what functionality must it have. So thank you very much for your time.
Thank you.